All right, good morning. Welcome back. So, hope everybody had a good weekend and got a bunch of stuff to talk about today. So, let me get stuff set up. All right, let's start by talking about homework 3. So, homework 3 is graded, and um, and I posted comments in Canvas along with your grade. So I tried your code on a number of different test cases, right? I tried running it the way that it's supposed to be run. Tried cases where I would win, cases where the computer would win, and then I tried badly behaved inputs. So specifying illegal entries for the number of sticks to begin with, specifying illegal entries for the number of sticks to take, and trying to error out by putting bad entries in that latter input twice in a row. So testing all of those cases, looked at your code, looked for coding style, commenting, things like that. Glanced at your log file from Git just to get an idea for how much you were using Git along the way. That doesn't affect your grade, but I just kind of wanted to get an idea. So first of all, by and large, really good job on homework 3. So most of the code that I looked at ran at least to some degree. Let me turn off my chimes here because we're still missing half the class, and that's going to be a lot of chimes. So most of the assignments ran to some degree of success. In many cases, they worked perfectly, and all the error handling and all the required interactions and so on looked perfect. So that was great. Most of the cases where there were issues with the code and point deductions boiled down to doing things in Bash that were not quite right. Using if with single brackets instead of doubles sometimes works, sometimes doesn't. Right? One place where it doesn't work is if you're expecting an integer and the person types in something that's not an integer, the single brackets will throw an error. Double brackets will suppress that. Not putting things in quotation marks when you're doing an equality comparison. Using a less than sign instead of -LT. Things like that. So not to sound like a broken record, but that's part of what being a teacher is sometimes. By and large, the people who wrote their Bash code in a way that used the constructs from that Bash how-to guide on Canvas generally got an A. And generally the people who did not get an A were doing different constructs. They were using single brackets, they were using parentheses, they were saying let, they were saying set, they were using less than or greater than symbols, and so on and so forth. And I want you to feel free and encouraged to, explore anything in this course and work with different things and learn different things. But if your goal is I just want to get this code written and I want it to make sense to me, right? Use that guide on Canvas. Okay, number one, that's the required set of constructs. And if you deviate from that, there's point loss, right? Including using for loops. And number two, that stuff will work. Okay, if you write an if exactly the way that it's described in there with the exact spacing and the double equal sign, the double brackets, and the new line for the word then, and so on, it will work, right? And so other than typos, you don't have to wonder, well, is this going to break when Nick tries running it? And I'll generally stress your code and try to find the weak spots in it to know if it's pretty solid code. Error handling was one issue, right? Being able to respond to non-numeric input when you're expecting a number, that's one thing. What else? Make sure your shebang, the number exclamation mark, is the first statement in your file. If it comes on the second line after your name, it's not a shebang. And if somebody who's not running Bash runs your code, it may not work, right? Because it'll run under whatever shell they're currently using. So shebang placement is critical. Um, yeah, and just test your code, right? Test it thoroughly. Um, I had a number of submissions that just would not run. That I would type in the name and it would start to execute and it would throw a syntax error and exit. Test it thoroughly, right? This is another reason to try to get your stuff done earlier than the deadline so that you have time to throw a lot of test cases at it. And it's important that it works the way you expect it to be used, right? But then you also want to try to throw unexpected things at it and see if it continues to work. So that's part of debugging, right? Doing the QA. Let's see, what else can I say about homework 3? And yeah, as long as you include everything, I don't mind if you have your bash script calling other scripts, long as they're all in the repository and I download them all. That's absolutely fine. So most people modularize, which is awesome, right? It's really useful to break things into pieces. Some people had difficulty doing functions, right? And there's different ways to do functions. But write test code, right, and explore that. Some people wrote separate scripts and then called one script from another, and that works perfectly well too. Gitwise. So you know, about 20% of the class did not have their submission correctly submitted on time, which is a 0, and that's horrible. I hate doing that because I know in some cases people have put in a lot of effort, and when I eventually did download their code worked perfectly, you know, or well enough to get, you know, a good grade, and it's a 0 because it wasn't there on time and I couldn't download it. That's really harsh, okay, but that's kind of the reality. Especially when you move on to a university. So, you know, for this course, I'm dropping the lowest programming assignment. So if that happened to you, right, it's not going to hurt your grade. That 0 will be dropped, okay? But some of the cases where homework 3 was not downloadable, I still haven't gotten a test case for homework 4. And there's a good chance that when homework 4 gets downloaded, whatever went wrong with homework 3 might go wrong with homework 4, and that's going to be another 0, and that won't get dropped. Right? So I asked people on Thursday to, you know, submit a trial homework 4 repo, put a README in there, add me as a reporter, send me an email. Well, a few people did that, a lot of people didn't. Do that today, okay? I'm not going to let you do that Thursday because that's going to be out of control, but do that today. If you don't know that I was able to download your homework 3 successfully, push homework 4 over, make me a reporter, send me an email. Hey, can you check homework 4 for me? Okay, a bunch of people did that like on Thursday right away. A lot of people didn't. So make sure that I can grade your work. Okay. All right, let's see. Homework 4 questions. So homework 4, you're redoing the stick game, but you're doing the program in C. And most people, I think they totally nailed the algorithm. And that's fantastic, right? Even if you had bash problems, if you know what the steps are that you want to have the code perform to play the game, right? That's the sort of fundamental challenge of programming is what are the steps I want the computer to do? And then there's writing the syntax correctly to get the computer to do it. But the algorithm, I think people were on top of, right? Which means that won't be an issue for homework 4. So that's promising. All right, so questions on homework 4. All right, so I posted a sample executable on the Linux server. It's under /temp. It's called stick, And you're invited / encouraged to use this to get an idea what my expectations are for homework 4. So /temp /stick. If I just run it like this, it works very much like homework 3. Ask me how many sticks I want to play with. I want to play with 21. The user's always going first, so there's no question there. And you can go through and play to the end, and you win or the computer wins. Okay. So here's the differences from homework 3, right? If I put in an illegal number of sticks, game is over. No discussion, no negotiation. If I put in something that's not an integer, wrong number of sticks, game is over. If I just hit the enter key, not an integer, wrong input, game is over. Okay, so that's one thing that's different from homework 3, where you would keep asking how many sticks. Okay, while you're playing the game, if you put in an illegal entry, if you put in things that aren't numbers, if you just hit the enter key, if you put in ridiculous inputs, it keeps asking you. It doesn't give up after 2 tries. Okay, that's the other big difference. Until eventually you make a correct choice, and then it keeps playing. Alright, the third difference from homework 3 is that you can specify a command line argument. So instead of having it ask me how many sticks, I can just put the number of sticks right here. I can say I want to play with 100 sticks. And it starts playing with 100 sticks. And it does not ask how many sticks do you want to play with. It takes it from this command line argument, this 100 right here. And for error handling, if that's an illegal number, bad number of sticks, game's over. If it's not a valid number, bad number of sticks, game is over. Don't turn around and say, oh, that wasn't valid, let me ask you again, how many sticks do you want to play with? Okay, no redos. And if they specify extra stuff on the command line, if they don't have exactly 1 argument or 0 arguments, that's a usage error, game over. Okay, must supply either 0 or 1 command line arguments. So I think you probably already know how to what the requirements are from talking about it last week and from looking at the assignment. But if you want to double check your understanding, or if you and a friend are disagreeing on what something is supposed to do, you can go back, run /temp /stick with or without command line arguments, and see what the goal is. Alright, and we're going to talk in detail today about command line arguments. That's the bulk of our lecture today, which somebody just asked in the chat. So we're going to talk about argc, argv pretty soon. Alright, so let's talk about the next ODP, which is 411. There's a 411B which opens tomorrow. Today we're doing 411. Okay, so check Canvas to see which ODP is open. So 411, you're writing another function. This function is called parse. Okay, and parse does the following. So parse will take a single argument, which is a char star. Okay, we're going to talk about char stars today and tomorrow, but this is basically a string. Okay, so here's the shortened version of pointers. Char star basically means string. And a string is really an array of characters. Okay, and we'll dig into that. All right, so your parse function receives a string, an array of characters, a char star. And if the string that it receives corresponds to a valid integer between 1 and 4, a 1, a 2, a 3, or a 4, just return that corresponding integer value. Okay, parse returns an int. So if the string looks like a 1, return the integer 1. If it looks like a 3, return the integer 3. Anything else, if it's not a valid integer, if it's empty, if it has, weird characters in it, return a -1. All right. So if the string is empty, if it starts with a non-digit, if it's bigger than 4, if it's less than 1, if it has strange stuff in it, etc., return -1. Otherwise, return the value of the integer represented by that string. And your string could be things like, quote 1, or quote 3, or quote bunch of spaces followed by a 3, or 2 zeros followed by a 2, or a 2 followed by a bunch of spaces, right? All of those are legal integers. That's 1, that's 3, that's 3, that's 2, that's 2. Okay, but XX, that's not a legal integer. Empty string is not a legal integer. Period is not a legal integer. Okay, so how do you know what's a legal integer? Use the scanf function. Okay, if scanf can't convert the argument to an integer, return -1. If it can convert it to an integer, use that integer. Okay, and just make sure it's between 1 and 4. So I don't want you to do any heavy lifting here. I don't want you to look at ASCII codes. I don't want you to look to see if the first character is a space, and if it is, check the second character, and all of that stuff. That's all the stuff that scanf does. scanf is a huge function. It does lots of processing. It's very sophisticated. Let's use scanf. Let's take all of the sophistication in that function and use that to our advantage to parse a string, turn it into an integer. So all you got to do for this ODP is take this argument, pass it to scanf. All right, so let's sketch out some code. So to prototype your function, you're going to say, so let's look at sample code. Code snippets. To prototype your function, you're going to say integer parse char star semicolon. This is called a function prototype. In your main program that you're going to write to test your parse function, you're going to want to say something like this, so that the compiler knows, hey, parse is a function, it takes a char star, it returns an int. When you actually write your function, so here's your actual parse function, you're going to do almost exactly the same thing. You're going to say integer parse char star, but then you got to name what the variable is going to be. So I don't know, I'll call this str for string, and then curly bracket, closing curly bracket. So the function prototype, right, you just name the type of variable, but you don't have to actually give the variable a name. When you declare the function, you have to also name the variable so that you can use it in here. And our whole process here is really just scanf. So scanf takes three things. The first thing is the string whose contents we're trying to parse or interpret. The second thing is the conversion string, which says how should we interpret this string. We want to interpret it as an integer. And the third thing is the funny ampersand variable, which has to be an int because we're saying %d, and we're saying save converted value in n in this case, because that's an n. All right, well, if the person passes you a string containing, 3, then when you call scanf, the value of n will be 3. Okay? But if they pass you a string containing hello, and you try to convert that, what's the value of n going to be? Well, it's not going to get changed. It's not going to get set by scanf. So we need to know if scanf succeeded in converting this string to an integer. And so we need to look at the return value from scanf. Okay, and this is an important terminology thing. When I talk about the return value from a function, I mean this variable right here, right? If I said r equal to function name, it's the value that r is going to get. That's the return value. Okay. Now, if we convert a string to an integer, then n is going to get, some new value to it. That's not what I mean by the return value. Okay, the return value of a function is always, the function value itself. So in this case, it would be r. And we interpret r as how many things were converted. So if r equals 1, then conversion succeeded. And n is the converted value. Alright, so with that in mind, how do we do ODP 411? Make your parse function. Take a char star, call your argument something like string, run it through scanf. Convert with a %d, save the result in n. Check the return value from scanf. If it's not 1, you did not find a valid integer, return -1 from the parse function. If the return value is 1, conversion succeeded. The value of the integer is in whatever you pass to scanf, n in this case. So now check n. If it's bigger than or equal to 1 and less than or equal to 4, just return n, because you're in one of these 4 cases. Otherwise, it's an integer, but it's out of bounds, return -1. Alright, so this is a call to scanf. It's an if statement and a return statement, and not a whole lot else. Let's see, do we have that if statement inside the parse function? Yeah, all of this has to go in your parse function, because that's the only thing that you have control over in the assessment. Right, so your goal of parse is to get back just one integer, and if it's an integer between 1 and 4, you know that string was a valid input between 1 and 4. If it's a -1, you know there was a problem with the input. And this is part of homework 4, right? So in your C code for the stick game, how many sticks would you like to take? The person types in a response. You save that as a string, and you just call parse. And if parse returns -1, sorry there was a problem with your input, how many sticks would you like to take? Ask them again. If parse returns something other than -1, it will be a number saying how many sticks they wanted to take. And you subtract that from your pile, and you go on from there. So this will be part this could be part of homework 4. Alright, so what do you do with all of this? You write your parse function, and then you write a main program to test it. And you got to test it yourself. Don't try to use the assessment code to do the testing. Write your own test code. So how do you do that? Testing it. Prototype your function. Right, main function. What do? I don't know. Integer result. Let's just call parse. Let's pass it the string 2. And let's save the return value from parse in this variable called result. And let's just say parse return %d and print out the result. Alright. 2 or 3 line main program to test my parse function. I'm going to call parse, I'm going to pass it a 2 as a string, so I'm putting it inside double quotes. And parse should do its thing. It should look at that, it should convert it to a 2, it should say it's in range, it should return a 2. So let's see what parse returned. Parse returned and print out the value of that result. Now do this like 10 or 15 times and try lots of different strings. Right? Try a 3. Try a 3 with spaces in front of it. Try a 2 with zeros in front. Try some illegal things. Try a totally empty string. Try a string with a period, right? And make sure that in these cases the result is 1, 3, 3, 2, 2. In these cases the result is -1, -1, -1. And come up with your own test cases, right? Experiment with it. Try to break it. Try to get it to misbehave. Try to get it to segfault, right? The one thing I'll tell you, if you're thinking ahead and you know more about pointers, I will not test this with a null string, okay? I'll always pass a valid string to parse. So you don't need to check if the string is null. If that doesn't make sense to you, don't worry about it. But I won't be that badly behaved that I'll pass a null string. I'll always pass a valid string, and you just need to parse it and see if it's an integer and if it's between 1 and 4. So write your main program, link it with your parser, make an executable, I'm calling it main, run that, test it. Okay. Once you've done all that and you're pretty sure that your parse function works, then you're ready to assess it. So link it with the test bed, right? So compile it with /temp odp411 main.o, call your executable odp411, and then assess like that. Executable program, source code for your function. You should get 40 out of 40. Let's see, could we still adapt our program to that to be thorough? Yeah, if you want, you could check to see, before you do the scanf, check to see if the argument is equal to null, and if it is, return -1. And then you got a nice bulletproof piece of code. That won't interfere with the assessment. I just didn't want to get into dealing with null strings at this point. Alright, and again, remember, your parse function does not generate any output. It should never print a message like, you know, illegal number detected, returning -1. That'll kill the assessment, okay? And you don't want a function to be overly talkative, right? Think of the mentality of, if everything is good, there's no need to say anything, right? You only say something when there's a problem and the person needs to know about it. The person expects the function to work, right? So if it works, you don't have to say function succeeded in converting one argument or something like that. So everything's going to be silent. And if there's a problem, you return a code, -1 in this case, saying, hey, there's a problem. The person who called your function, they might decide to say, you know, that was an illegal entry. Or they might decide to do something different, but let the caller make that decision, right? Just give them the information they need by returning a -1. Okay, I can't think of anything else I could possibly say about ODP411. So 411B opens tomorrow, and that's going to be a slightly fancier version of 411. Okay. All right, there's an online quiz that I posted. It's due Wednesday afternoon. There's nothing to figure out for this quiz. It's a lab exercise. It basically gives you a short C program, several lines of code. I want you to type those in, right, with an editor on the Linux server, compile it, run it, put in the input that's specified, and report on what happens. The second question uses the same code. Sorry, the second question is a different set of code. Type that in, compile it, run it, put in the specified input, report what happens. The third question is the same code but a different input. So just rerun the code, put in that different input, report what happens. And then the fourth question is a third set of code. Type that in, compile it, run it, type in the input, report what happens. Okay, there's nothing to figure out. There's nothing to you know, Google or reverse engineer or anything. It's really just a lab exercise. But I want you to go through the process of putting in these 3 different sets of code, running them, seeing what happens with different inputs, and thinking about what that means. And this is in the vein of why we use fgets and scanf instead of just using scanf. And so some of that code will just use scanf, and you'll see some of the issues that you can get into with that. And some of the code will use fgets and scanf together, and you'll see how we can avoid those issues. Let's see, question. If you specify what the message is in parse, then you can't change what it would say for a larger function, then again for a different one. So why is it there? Just practice. If you specify what the message is in parse. I don't think I understand that question. Then you can't change what it would say for a larger function, then again for a different one. Okay. All right. All right. So do that online quiz. Like I say, it's just a lab exercise, a series of steps to go through and then think about what's happening. But to do the quiz and get your 12 points, it's just a straightforward process. So do that before Wednesday. All right. Let's talk about argc and argv. So let's talk about command line arguments to functions. So we know in bash, when we type in the name of a script, it starts to execute the script. And we know that we can, on the same line where we type the name of the script, we can put in other information we want to pass to the script. And so in bash, we can say something like, you know, the name of some command. This is fun. Let's see. All right, I'm just going to write some code. I don't know if those dollar signs will print or not, but let's play with this. Okay, so if I just run this command go, right, it's a bash script, $ number is equal to 0. $1 and $2 are blank. If I say go hello, $ number is 1. And $1 is that first command line argument. $2 is blank. If I say go, this is fun, $ number is 3. Because I put 3 things after the word go, this is fun. $1 is this, $2 is, $3 presumably would be fun. Okay, so bash works pretty easily. $ number is 3. This is $1, this is $2, this is $3. Okay, C is similar but a little different. So first of all, how do we write things in C? Well, we specify a pair of arguments for our main function. And the first one has to be an integer, and the second one has to be a char star star. And we'll talk about char star stars and char stars more tomorrow probably. But the effect is this first argument, this argc, tells us how many things we have on the command line, how many arguments we have. So that's kind of like $number. Not exactly the same, but it's kind of like that. So let's take a look at this. All right, this is test code. I'm always going to tell you write test code. If you're trying to figure something out, write some code to dig into it. So I have an extremely simple main program which has one line of code to it, which just prints out the value of argc, which is this first argument. Okay. Now you can call these whatever you want. I could call this Betty and Barney, right? But this first argument has to be an integer. The second argument has to be a char star star. But the tradition is we call this argc, which is argument count, and we call this argv because it's a vector of arguments. And if you call it anything other than that, people will either think you're eccentric or inexperienced. So I'm going to call them argc and argv, and let's just print out the value of argc and see what it looks like. So let's hop over here. Let's compile our code and let's run it. So if I run it just like that, just by typing the name of the command, it tells me argc equals 1. If I say go hello, argc is 2. If I say go abc, argc is 4. If I say go, this is not much fun with a typo, argc is 6. So what is argc? 1, 2, 3, 4, 5, 6 words up here, argc is 6. Go, hello, 2 words, argc is 2. Go, just 1 word, argc is 1. So argc has a really straightforward interpretation. It's the number of words that you put on the command line when you ran your program, including the name of the program itself. So this is where it differs from bash, because bash, remember, if we said command this is fun, $number was 3 because we put 3 things after the name of the program. Okay? For C, argc would return 1, 2, 3, 4. It's the total number of things on the command line. Alright, go, hello, 2 things, argc is 2. Alright, so argc is the number of things on the command line, including the name of the command itself. Alright, what about argv? Argv is a vector or an array of strings. So if that's how we set up our main program, this is the number of arguments. Argv is an array of strings. I'm adding extra spaces in here. Alright, that's all you need to know about argv. Argv 0 will be the first thing you put on the command line. Argv bracket 1 will be the second thing you put on the command line. Argv bracket 3 will be the fourth thing that you put on the command line, and so on. Okay, arrays start from 0. That's important to keep in mind. And argv is an array, and each thing in that array is a string. It's a char star. Alright, so in this particular case, what's argc going to be equal to? 1, 2, 3, 4, 5 things on the command line. Right? If there's 5 things on the command line, they are numbered in the array bracket 0, 1, 2, 3, and 4. So whatever argc is, the last argument is always argv bracket argc minus 1. So let's look at the elements in argv. So we want I to start from 0, and we want to go up to and including argc minus 1. And let's just print these out. Alright, so I'll print out the value of I right here, and I'll print out the value of argv bracket I right here. So if I say go, argc is 1, argv bracket 0 is just go. If I say go back, argc is 2, first element of the array is go, second element of the array is back. If I say go 1, 2, 3, 4, argc is 5, and the 5 elements of my array are go 1, 2, 3, 4. Okay, it's really that straightforward. argc tells you how many things are on this command line, and argv bracket 0 through argc minus 1 gives you access to those strings containing each of those things on the command line. And the one kind of oddity here, right? So go, this is an argue comment with spaces inside, ha ha ha. argc is just 4. This is the first thing on the command line, this is the second thing. All of this is the third thing. The quotation marks group things together in bash and make them a single thing. And then the fourth argument was ha ha. So argv bracket 0 is go, followed by this, followed by all that stuff I had in quotes, including the trailing spaces, followed by ha ha. That's a little bit of an edge case, but just so you've seen it. All right. So what does this tell us? It tells us that if we want to know how many things we have in our command line, the right way to know that is to look at argc. Okay, so let's do something different in here. Go ahead and include string.h. So suppose we want to know if argument 2, which would be the third thing on the command line, is missing, and we say, well, let's check the string length of it. And if it's 0, then we'll say we found an empty string. Okay, so that might seem like a reasonable thing to do. So if I say go, well, it didn't say that in fact. And if I say go what, I get a seg fault. Okay, why am I getting a seg fault? Because I'm trying to do something with argv bracket 2, and I don't know if I have an argv bracket 2. Right? If I have, 1, 2, 3, 4, 5, 6, if I have, all of these things on the command line, I can access those using the argv array. But if this was what the input was, I never want to do something with argv bracket 5. So let me add a comment here. If I try to use argv bracket 5 in this case, I'll possibly seg fault. So anytime that you want to do something with an element of the argv array, before you do that, you got to check argc. Make sure that argc tells you that that element does exist. And if argc is 5, you can use argv 0 through 4, right? Because you have 5 arguments. Don't ever use argc 5, 6, 7, 8, 10. Okay? Anytime you're going to use argv bracket I, make sure you have at least I plus 1 arguments by checking argc. Okay, so if you get seg faults, come back to this example. Alright, questions about that? We're not done with this topic, but this is a first pass. Alright, I'll push this code over to the code area on Canvas. So we'll come back to this tomorrow. We'll look at the next ODP for sure. But then I want to talk about this car star business, what exactly is going on with that. And then I want to talk about car star versus car buffer bracket 120, for example. And then we'll dig back into scanf and fgets and look at that with respect to the next ODP. And then I still want to go back and finish talking about VI, so we'll do that sometime this week. All right, we're out of time. Have a good one. I will see you next time. Thank you.